All right, working on the 3.4 worksheet, guys. Some people had questions about this. So what you were given at the top here of the whole side, the whole page, was that the x-coordinate right here of a particle moving on the line y equals 2 is given to you by this function right over here. Now, it was a long time ago when I wrote this problem. The line y equals 2 is just kind of this random thing that the particle seems to be moving along, so it's moving back and forth and back and forth. So I don't want you guys to worry at all about the fact that the y-coordinate of this point here is 2, because if it's moving on the line y equals 2, a horizontal line, its y-coordinate will always be 2. So that's irrelevant. What we really need to focus on is the fact that its x-coordinate here, or in this case, it's really its t-coordinate, is going to be 5. So how are we going to handle this problem? We're going to take our position function, x of t, which was given, I'll write it out here, 2t cubed minus 13t squared plus 22t minus 5, and we want to know where the x-coordinate of this particle's position is 5. So I'm taking the 5 that was given to us here, and that's where that's coming from. Now, kudos to you guys if you tried to take a look at this function and said, am I supposed to be able to solve this by hand? You've done a little bit of solving cubic polynomial equations by hand over the last couple of years, but this one, guys, I am pretty certain, no, in fact, I'm really certain, does not work out at all. Why? There's really no factoring that you can do right here, because the only method we ever really learned for factoring by four-term polynomials would be by grouping. Now, even if I brought this 5 over here and made that a minus 10, and this would be 0, the ratio of 2 to 13 is not the same as the ratio of 22 to 10. Doesn't work out at all. So the good news for you guys then is we're going to go right to our calculator now and just let the calculator solve that equation for us. So what I want you guys to get used to is the idea right here that on calculator questions on a quiz or a test, all you guys really need to do is show me what the equation was and then go to your calculator and tell me the answers there. We don't need to do anything else. Now, I decided to save time here, because it'd be a little boring for you guys to watch me type this in. So I've already defined this function in my calculator. Now you'll notice instead of calling it x of t, I've called it f1 of x, just because that works a little bit better in the calculator. It's a little bit easier, but whatever you guys want to do is fine. Now what I want to do is find out when this equation is equal to 5. So I'm going to hit my tools menu, guys. For you, it's menu. We're going to go to algebra, and we're going to go solve. So I believe that's menu 31 for you guys. And now I'm going to go ahead and save myself a little time here. We can define it, we can name it in the calculator the way we've already defined it. I called it f1 of x. You guys can write whatever you typed it in as right here, and I want to know when that function is equal to 5. Now remember, before you hit enter, you always have to put a comma here at the end of that and tell the calculator which variable you want it to solve this equation for. Well, for me, that's going to be an x, and when I hit enter, it looks like I've gotten 3 solutions right here, which doesn't surprise me. Why? Because this is a cubic polynomial equation right here, and the fundamental theorem of algebra, which you guys have learned for the last couple of years, should tell you here that a cubic polynomial can have at most 3 solutions, and that's what it looks like we found here, guys. So we're going to write each one of those down. Now, unfortunately, they are irrational, so we're going to have to round them. So our first one looks like 0.745. Let me write that, 0.745. Really, the word or goes in between all of these. Next solution is going to be 1.626. Gotcha. And then another or, t equals, and it looks like our last solution now, 4.129, if we were going to round that one, 4.129. Okay, that's what we've got. And for part A, they wanted to know when the particle has a position of x equals 5. That's it, guys. That is the answer to part A of this question. We took our position function, set it equal to 5, and solved and got these 3 solutions. Let's move on to part B. When is the particle at rest? So we need to understand something important, guys, that this phrase right here, at rest, means something very specific. It means that the velocity of your object has to equal 0. For something to be at rest, it's not moving left or right or up or down, so its velocity is not positive nor negative. It has to be 0. So we've got to come up with our velocity function, and how do we do that? By taking the derivative of the position function. That is the main takeaway, everybody, from section 3.4. So here we go. Derivative of 2t cubed is going to be a 6t squared, and then minus 13 times 2 is going to be a 26t, and then a plus 22 at the end of all that. There's our velocity function, and we need to set that equal to 0 and solve. Now again, I'd be proud of you guys if you tried to solve this thing by factoring, but I don't think this one is going to work. A little trick that I've shown you guys before, if you remember the discriminant from your quadratic formula, b squared minus 4ac, that will tell you whether this thing is going to factor or not. So for us, let's see, our b squared, that's negative 26, but I'm going to square it so it can stay positive. So let me just type that in. 26 squared, that's b squared, minus 4 times an a value of, I think, 2, and then a c value of, was it 22? Oh, I'm sorry, a was 6, and c was 22 there. I better fix that. Whoop, 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 I broke it. Where'd we go here, guys? I'm sorry. So let's see. It was 26 squared minus 4 times an a value of 6 and a c value of 22. We got 148, which is positive. That's the number we would be taking the square root of if we were doing the quadratic formula right here. So the fact that it's positive at least tells me that we have two real roots. However, this number right here is not a perfect square. Remember, the discriminant is what you would be taking the square root of in the quadratic formula. So that means we'd be taking the square root of 148. Since that's not a perfect square, this is not going to work out that nicely. We're going to end up then with irrational solutions. And that tells me there is really no point in trying to factor this thing because it's not going to work out, and that means we might as well just go ahead and use our calculator to solve this quadratic equation here. So let's hop back here and let's do this again. Again, menu 31 for you guys, and we're going to solve this equation here, which was 6. I'm just going to go with x squared. Then what? It was a minus 26x, and then I believe a plus 22, and we wanted to know when that was equal to 0, comma, and we want to solve that for x. Let me make real sure I got that right. 6x squared minus 26x and a plus 22. Okay, got it. And let's hit enter. Okay, and we got two values right here. 1.153 looks like the first one right here. I guess I'll do that in blue. Okay, 1.153, or the second one we got was t equals 3.180. Now, just a quick reminder, guys, it's tempting sometimes to leave off that 0 at the end, but kind of like significant digits in science, we need that third digit to show that we've rounded to the thousandths place. Otherwise, if we just wrote 3.18, that would make it look like we only rounded to the hundredths place, and it would be less precise. Now, these are the two answers we got, and I am done with part B, but I want to make sure that everybody understands something important right here. Give me just a second, guys. I am going to copy those values, and I want to go back to the answer that I came up with right here in part A. Oh, shoot, that didn't do what I wanted it to do. All right, let's try that again. So if I did all of this now and said, okay, let's copy that, I want you guys to compare these answers that we just came up with in part B to the answers that we initially had in part A. And what I want you guys to notice here is that this value, when the particle is at rest, is in between the first and the second time when the particle was at a spot where x is equal to 5. What that tells us, everybody, is that the object here passed through a particular point. then it came to rest, and then later it went back through the same point again. Most likely the object changed direction. And then sure enough, there's another spot where the object is at rest, and that comes in between the second and the third time when the object is at 5. So the fact that I got 2 spots here where the object is at rest, and it happened in between these 3 times here where the object's position was at 5, makes me feel like we're in good shape and we're probably doing this problem correctly. Now, this, part C, is going to kind of tie all of that together, guys. Describe the motion of the particle for t is equal to 0. So what I'm going to do, actually, this works out really well. If I go back to my answers here from the previous spots right here, these were the 2 times, everybody, at which, get rid of this guy, at which the object was at rest. Now that means that every other time, other than these ones right here, the object either had to be moving to the left or to the right. So this is going to be the first time I'm going to show you guys what's called a sign chart here. Real simple, all right? We've got these 2 values at which velocity was equal to 0. And that means that everywhere else, velocity was either positive or negative. Now let's find out. What I'm going to do here, guys, is I'm going to choose a time value less than 1.13. So I'm going to go with t equals 1. Then in the middle here, I'm going to pick something between this value and this value. How about t equals 2? And then all the way on the right, I'm going to pick something bigger than 3.180. How about t equals 4? And where am I going to put those? Into the velocity function. So v of 1. Then I'm going to find v of 2, and then we're going to find v of 4. Now, I don't really care what the actual numerical value of those things are. I really just care about the sign. So how am I going to do that, guys? Probably not a bad idea to define this velocity function in my calculator. So let me call this, oh, it's a pain here for me. You guys could just call it v of t, that's fine. I'm going to call this thing f2 of x. Getting to v on the iPad app is a pain in the neck. All right, so that velocity function we came up with then was, I've actually got it right above there, it was 6x squared and a minus 26x and then a plus 22. Okay, so there's our velocity function, and we now want to evaluate, let's see, f2 is what I called it, and our first test value I think was 1, and we got 2. Okay, so velocity at 1 was 2. Again, I don't really care about the 2, but it's positive. And that means that the object was moving. Now remember, we're moving along a horizontal line in this problem, guys, along the line y equals 2. So that means that our object is moving right. For all t, I don't know what I want to say right here, the interval from 0 to 1.153 seconds. Guys, remember, this is the important value here. That's why I put a big box around it. This t equals 1 was just a test value. So that's the first answer to my question. When it said describe the motion of the particle, it's moving right on the interval from 0 to 1.153. I do not want to make an assumption, guys, although I think a lot of you will, that because it was moving right, then it came to a rest. Don't make the assumption that it's automatically moving left now. We've got to test v of 2. So for me, that is going to be f2 of 2. And what did we get? Okay, we got a negative value right then. v2 was negative, and that means that this object, this particle, is moving left on an interval right here. I wrote 4, you could say on, that's fine as well, from 1.153 seconds up to 3.180 seconds. And there's the second answer to my question. And lastly, v of 4. Once again, guys, I do not want to make an assumption, and I don't want you guys to get in that habit either, so we always want to test v2, and we plugged in 4, I think, and now we got a positive number yet again. So if v4 is positive, that tells me one more time that this object is moving to the right on or for an interval that starts at 3.180 and ends when? Well, they never said anything in this problem about when this experiment ends. That means that this thing is going to keep moving right ad nauseum, everybody, until infinity right there. So these are the 3 parts to our answer here for number 1C. So what did we do? We found where the velocity of our object was equal to 0. That happened here, and it happened here, and then we chose 3 test values. All right, one to the left, one in the middle, and one in the right of the 2 times when the object was at rest, and then we chose those test values, plugged them into our velocity function, and looked at the sign of our velocity to tell us which direction this object was moving. All right, guys, a lot of work there, but that's a wrap on problem number 1 on the 3.4 worksheet.